welcome back to the Math Society. So this week we'll be doing probability, which is another episode topic. So let's get right into it.
Okay, so for the first question, it says that 30 people travel from London to Manchester for a conference. Of these people, 15 travel by plane, 15 travel by train, 9 travel by plane, some travel by both train and plane, 12 did not travel by either train or plane. So I think this will be better if you can draw a Venn diagram. And it says that 3 people chosen at random, and find the probability that exactly 2 of the people also travel by train. So let's try to find let's try to draw the Venn diagram. Let me just make it a little rounder. Yep. And it says 15 travel by train, so this is going to be train, and it's going to be plane. Just write E here. 15 travel by plane, and then 15 travel by train, 9 travel by plane. Some did not travel, 12 did not travel by either train or plane. So we know that some travel by both train and plane, but it's an unknown, so we can going to leave it as X. So we have 30 people in total, so we can try to find X, right? But then we know that we still need to minus X because X is the common where they travel by both train and plane. So it will be 15 minus X plus 9 minus X plus 12. That's going to equals to the total, which is 30. So then you should get 36 minus X, that's equal to 30, and X is equal to 6. So now X is equal to 6, right? So 15 minus 6, that's 9. 9 minus 6, that's 3. And it says that 3 people are chosen at random from those who travel by plane. Find the probability that exactly 2 of these people also travel by train. So exactly 2 of these people. So we need to choose from like the middle where they travel by boat. So that's going to be 6 by 9 multiply, and then second probability. So they also choose 2 people, right, that travel by boat. 5 by 8 multiply, and then another one is that one of the person is only going to travel by plane. So we're gonna have to choose from 3. So that's going to be 3 by 7, and it's going to equals to 90 by 504. And we want to know it's 3 people, so 90 by 504 multiply 3, well, it's equal to 15 by 28. And that's your answer. And then we will move to question 2. It says that during a week, 500 trains will arrive at a station. Each train will be late, on time, or early. The probability of a train arriving late is 0.85. Probability of a train arriving on time is 0.07. So calculate an estimate number of trains that will arrive early during the week. So we don't know what probability it is to arrive early, so we can try to find the early probability first. So early, and you know the total probability is 1, so that's 1 minus 0.85 minus 0.07, which you will get 0.08. And we want to know how many trains arrive early, so it's 0.08 multiply 500, and then we get an answer of 40 trains that will arrive early. Okay, so now we go on to question 3. So question 3 says that when Joe goes to school, the probability that he wears a coat is 5 by 8. And if he wears a coat, the probability that he wears a scarf is 1 by 4. If he does not wear a coat, the probability that he wears a scarf is 1 by 6. Complete the probability tree diagram. So we know that he wears a coat, 5 by 8. So the probability that he doesn't wear a coat is 3 by 8. And the probability if he wears a coat, the probability that he wears a scarf is 1 by 4. That's 3 by 4. And if he doesn't wear the coat, the probability that he wears a scarf is 1 by 6. And this should be 5 by 6. And that's completing the tree diagram. And B, it says on a day Joe goes to school in winter, calculate the probability that B, he is not wearing a coat and not wearing a scarf. Not wearing a coat, 3 by 8. Not wearing a scarf, 5 by 6. So that's 3 by 8 multiply 5 by 6, which is equal to 5 by 16. And C, he is wearing a coat or he's wearing a scarf, but he's not wearing both and a coat and scarf. So on a day Joe goes to school in winter, so he might be either wearing either one of them but not both. So we can try to find it as if he is wearing a coat, which is 5 by 8, he will not be wearing a scarf, right? Which is 3 by 4. And if he is not wearing a coat, which is 3 by 8, he will be wearing a scarf, which is 1 by 6. So if you add them together, you should get 17. Let me just write it again. You should get 17 by 32. That should be your probability. And then D. On the day Joe goes to school in winter, if he is wearing a coat and a scarf, then the probability that he is also wearing a hat is 3 by 5. Calculate on the probability that on the day Joe goes to school in winter, he is not wearing all three of a coat, a scarf, or a hat. So we just need to subtract from the probability of one where he is wearing all three, because we don't want the probability where he is wearing all three. So we just need to subtract it. So we'll get the probability where he might be wearing a hat, but he might not be wearing the other two, or he might wearing a scarf, but he's not wearing the others. So we will just calculate as 1 minus, if he is wearing a scarf, which is, a coat, that is 5 by 8. And wearing a scarf, that should be, I think should be 1 by 4, yeah? 1 by 4, and he's always 3 by 5. 1 minus probability, you will get 29 minus 32, and that should be your answer. Okay, so now number 4, they say Aria has a base 5-sided spinner. When the spinner is spun once, it can land on a blue or yellow or green or pink or orange. Anya spins the spinner many times and records the color the spinner lands on each time. She uses these results to calculate the probability of the spinner landing on each color. So, say that table gives them the probability. Aria's color show the probability of the spinner landing on orange is 3 times. So that's like, we can just give it as like 3x and x, because it says 3 times. And we know that the total probability is 1, right? So we can find pink and orange. So that would be 4x plus 0.22 plus 0.34 plus 0.12. That is equal to 1. So 4x equals to 0.32. X should equal to 0.08. So 3x, orange would be 0.24. That's 0.08 and 0.24. So when R spin the spinner, it landed on green 90 times. Work on the estimate 90 times. So that's 90 green, which is 0.12. So then you should get 750 times that she spin the spinner. Okay, so number 5, Arthur has 10 cards. Each card has a letter on it that spells the word Piccadilly. So Arthur selects random at 3, calculate the probability that he result PAL in that order. So we know that we have 10. P, right? 1 by 10, multiply 1 by 9, multiply L, we got 2, so that's 2 by 8. Should get 1 by 360. Yep. And then, okay, 6. So 6, Harvey has 2 bags of counters, bag A and bag B. Bag A contains 8 red counters, 3 orange counters, and 4 yellow counters only. So 8 red, 3 orange, 4 yellow. Bag B contains 3 red, 2 orange, and 5 green. You take a random at 1 counter for bag A and 1 counter for bag B. Complete the probability tree diagram on the opposite page. Okay, he takes 8 by 15 of red, so 3 orange and 4 yellow. 3 orange, 4 yellow. And then it says that bag B contains 3 red counter, 2 orange, 5 green, so that's 10. 3 red, 2 orange, 5 green. Yep, and it should be the same. Okay, so now we're done with A. B, it says that calculate the probability the 2 counters have different colors. Harvey replaced the counter in the bag. Also, that's C. So B says that when he takes different colors. So we have to write down the color combinations that can be possible. We have 3 colors: red, orange, yellow. So it can be red, orange, red, green, or orange, red, orange, green, or yellow, red, or yellow green. Right, so there we just need to multiply there. So red orange, which is 8 by 15 and 2 by 10. Plus red green, 8 by 15. I think green was 5 by 10. Orange was 3 by 15 multiply. Red was 3 by 10. Orange 3 by 15. Green was 5 by 10. Yellow was 4, I think. Yep, 4 by 15. Multiply red, which was 3 by 10. Plus yellow and green, that is 4 by 15. Multiply 2 by 10. Plus oh, we forgot one, which is yellow and orange. Yep, this is the orange one, and then it's 4 by 15 multiply 5 by 10. So total you should get 4 by 5 probability. Yep. And then we'll move on to number C. It says that Harvey replaces the counters in the bags from which he took the counters. Chen has a bag C that contains 10 red counters and 8 orange counters only. So Chen takes a random 1 counter for bag A, 1 counter for bag B, and 1 counter for bag C. Probability that all 3 counters are taken have the same color is 1 by 15. Find the value of X. So we know that 10 red counters, 8 orange counters. So red was 8 by 15. Let's multiply another red, which was 3 by 10. Multiply with 10 by 10 plus X, yeah? Unknown plus 3 by 15. Multiply. Should be 2 by 10. Orange. Multiply X by X plus 10. And that equals to 1 by 15. So then we'll calculate this, where you will get 50, 240 plus 6x. That equals to 150 x plus 10. Which you will get 3600 plus 90x equals 150x plus 1500. 2160x. X equal 35. And they just asked for x, so x is equal to 35. Okay, we now go to 7. 7 says that Jill travels to work either by car or by train. Every day that she travels to work, probably she traveled by train is 0.1. Work by train late is 0.05. Car late is 0.01. So Anna randomly chosen to travel where she's late for work. Travel to work by train. So we know that she work with cars should be late would be 0.01 multiply 0.05 indicates that she is late, so that's 0.005. And 0.005 in the late that she travels by train, that's 0.9 multiply 0.01. So that's gonna equal to 0.0014, and 0.005 divided by 0.0014, which you will get 5514. And that is your probability. And we move on to number 8. Number 8 it says that there are 12 marbles in bag A and 15 marbles in bag B. In bag A, 7 yellow marbles, 5 red marbles. Bag B, 10 yellow, 5 red. Eugene takes a random 1 marble from bag A and without looking at the marble, puts the marble into bag B. And then takes 1 from bag A and takes a random 2 from bag B, places the 3 marbles that all have the same color. We need to know if they have the same color or not. So let's try to write A after transfer. So A first. So we know that originally it was 7, 5. So that's 12. That's yellow, red, 7 by 12. 5 by 12. Then we take again, red and yellow. That's after transfer, which is going to be 5 by 11 or 6 by 11. And this one's the same. We just red, yellow. That is 4 by 11 or 7 by 11. And then B is a yellow that we know is 10 by 15 or 5 by 15. That's a yellow. And here we know that yellow red would be 7 by 12 multiply 5 by 11, because we're gonna like take and then like puts it into back B. So we need to make sure that it's 5 by 12 multiply 6 by 11 should multiply 6 by 11. So when you take, because you're gonna take 3, and then 5 by 12 multiply 4 by 11. In yellow, so we know that it will be, if they put it, because they're gonna put it into the next bag as well, which is going to be red, is going to be 5 by 16 multiply, and it's gonna be 4 by 15, right? Because it has to be the same color. And 11 by 16, because it's yellow, multiply 10 by 5. Oh, sorry, 10 by 15, I mean. And it'll be 6 by 16 again, multiply 5 by 15. And 10 by 16 multiply 9 by 15, because they have to be, yeah, we have to find the fact that where they all have the same color. And we just need to multiply all these, and then we will have the total. So red, that goes from A to B, where you would get 3 yellows. That is going to be 5 by 12 multiply 7 by 11, 7 by 11 multiply 10 by 6, 10 by 16 multiply 9 by 15. That should be 35 by 352. And another one is R, A to B, where they will have 3 R's. So that is 5 by 12 multiply 4 by 11 multiply 6 by 16 multiply 5 by 15, where you will get 5 by 264. And Y from A to B, so where you will have Y, Y, Y. And that will be 7 by 12 multiply 6 by 11 multiply 11 by 16 multiply 10 by 15. So that's 7 by 48. And Y, A to B, where you will have R, R, R. So that's 7 by 12 multiply 5 by 11 multiply 5 by 16 multiply 4 by 15. That's equal to 35 by 1584. Yeah, so now we just need to calculate the total of how many it would be in total. So it should be 35 by 352 35 by 352 plus 5 by 264 plus 7 by 48 plus 35 by 1584. That should equal to 907 by 3168, and that is your total. Okay, so for number 9, it says that over the course of a week of 7 days, Alan plays a series of games. So on Sunday, probably that he wins it 1 by 2. So first of all, for day Sunday is 1 by 7, right? And the other day is not Sunday, 6 by 7. Probably he wins his half, so that's half as well. And the fact that Alan probably wins on other days other than Sunday is 1 by 3, so that's 2 by 3. So expected number, so that means if it's on Sunday, which is 1 by 7, he wins half, right? So he has a probability of winning half. And if it's not on Sunday, he has a probability of winning 1 by 3. And in a span of 7 days. So then total should be 2.5. And that's the number of games that he's expected to win. And number 10, it says that Ramesh, Maya, Kylie, Chen, and Andrea have a bag containing an identical set of 6 cards. There's a number. Ramesh takes one of the 6 cards. A, right? Then the probability that the number of the card Ramesh takes is a prime number. So we know that prime number is just 2 and 7. So that's 2 by 6. So that's 1 by 3. Yep. And Maya takes a random from a bag 2 of the 6 cards in the back. Find probably that neither of the 2 cards has a number 4 on it. So we need to make sure that it's not number 4. So then we may take 4 by 6 and 3 by 5. So that's going to be 2 by 5, right? And we need to make sure that Kali takes a random from his bag 2 of the 6 cards in his bag. Find the probability that the total of the number of the card is 11. So to get 11, we know that 9 plus 2 has to be 11. And then 7 plus 4 has to be 11. So now we will try to calculate, which should be 2. We know 1 by 6, right? That's 1 by 6 multiply 1 by 5 plus 2. Another one is 4. 4 is 2, right? There's 2 numbers, so that's 2 by 6 multiply 1 by 5, where there's only 1 7. Yep, so it should be the answer should be 1 by 5. And Chen takes a random 1 card at a time without replacement from her bag until she gets a card with a number 4 on it. She then stops taking cards from the bag. Find the probability that Chen stops taking cards from the bag before she takes a 4th card. So we need to make sure that it is there's no until she gets the number 4. So then we know that it will be 2 by 6 because that's 4. It has 2. That's gonna be plus 4 by 6 multiply 2 by 5. And then it's 4 by 6 multiply 3 by 5 multiply 2 by 4. That's going to equal 4 by 5. And that should be our answer. And Andrea puts another card with a number on in her back so that she has 7 cards in the total. The mean is 8. Find the value of the card that Andrea put into the back. So that's 2 plus 4 plus 4 plus 7 plus 9 plus 10. Unknown number x, so that's 7 in total equals the mean, which is 8. So then we can just find x is equal to 56 minus 36, which you would get an answer of 20, which is x is equal to 20. Okay, so 11. So it says that there are 45 young people in a youth club. Find the class interval that contains a median. So median, we just need to know how much is the median alpha. We know 45, so that's going to be, if you divide by 2, that is 2, 4, 24, close to 24. So it should be in the interval here, which is 155 ish and 60. Okay, number B says that calculate an estimate mean of the height. So we just need to multiply all these with median and then find the height. So it should be 145 multiply 5 plus 152.5 multiply 8 plus 157.5 multiply 11 plus 162.5 multiply 6 plus 167.5 multiply 12 plus 180 multiply 3, and that's divided by 45, which you will get an answer of 160.1, and that's an estimate of the mean. And it says that one of the young people is selected at random. The incomplete probability tree diagram on the opposite page gives information of the hair color of this young person. Okay, here. So this is the probability tree diagram. You know that one should be 5 by 9 because it's 4 by 9. 1 by 3, so that's 2 by 3. 3 by 5, so that's 2 by 5. And we just need to complete the probability tree diagram. And given that of the hair color is independent, right? Calculated probability that young person selected has fair hair and height of more than 160. So we need to know if they have more than 160 or not. So let's try to multiply. So of more than 160, we need to find more than 160, right? So that's these numbers. So that's going to be 21 by 45, right? Multiply days fair hair and a height of more. So it can be blue color eyes, but then height and it has to be a fair. So that's 4 by 9 plus 21 by 45 multiply 2 by 3, which is multiply 3 by 5. Which you will get an answer of 518 by 2025, and that is your answer. Okay, so now we move on to question number 12. It says that Nita is going to play 1 game of chess and 1 game of snooker. Probably that she will win the game of chess is 0.35. Probably that she will win a game of snooker is 0.48. So snooker 0.48, that's how she will win. So we need to just do the, because it says independent, yeah, they're not dependent on each other. So that's going to be 0.65, 0.52, and it's also 0.52. So it's find the probability that Nina will win only one of the game. We just need to know only one. So if she wins chess, she's not gonna win snooker. So if she wins chess, which is 0.35, she will not win the snooker, which is 0.52. Plus, if she doesn't win chess, she will win the snooker game, which is 0.48. If you add them together, you should get 0.494, and that is the probability. And then we move on to question number 13. It says that table gives information on the weights in grams, estimate mean. So we need to find the mean and multiply them again. So mean should be equals to 18 multiplied 8 plus 20 multiplied 3 plus 21.5 multiplied 15 plus 22.5 multiplied 8 plus 24 multiplied 6, and that is divided by the total of 40. We should get an answer of 21.3. That's the mean weight. One of these I don't want it, might is selected at random, so find a probability weight less than 22 grams. Less than 22 grams, so it has to be less than 22, yeah? So then we'll have here until here, so it's going to be 26 by 40, and that is 13 by 20, and that's your probability. And number 14, it says that a bag contains 20 balls. Each ball is either number 5 on it or number 6. There are 12 balls with number 5, 8 with number 6. Ben takes random 2 balls from the bag. Complete the probability tree diagram. So let's complete the tree diagram first. So for 5, it is, because if you take 1, you only have be left with 19. And then that should be 11, because he takes 12 balls with the number 5, right? Then this would be 8 by 19, because there will still be the number 6 ball. And this should be 8 by 20. And the same thing, 12 by 19. And 7 by 19, because this time it is the 6 that is taken. And B, it says that calculate the probability that the sum of the numbers of the 2 balls is greater than 10. Give your answer as a fraction. We just need to make sure that it's greater than 10. So has to be 5 and 6 or 6 and 5, right? Oh, I'm sorry, 6 and 5 or 6 and 6. So it will be 12 by 20 first. Plus 5 multiply 6, so that's 8 by 19. Plus, and 6 would be 8 by 20 multiply 12 by 19. And it can be 6 and 6, which is 8 by 20 multiply 7 by 19. And then you should get a total of 62 by 95. And that is your probability. Okay, so now we're on to number 15. So it says Peter has 2 boxes of bricks. Box A and B. Each box only contains red, green bricks, and yellow bricks. In box A, there are 15 of bricks, which are 5 for red, 7 green, 3 yellow, 5 red, 7 green, 3 yellow. Box B, 28 red, 9 green, 3 yellow. So we just need to complete the tree diagram first. So 5 in first one, 7 green. So that's 7 by 15. And then it is 3 yellow, so 3 by 15. And then in the second box, 8 are red. Well, let's see the total. So that is 20. And then green was 9, I think. 9 and 3. 3 by 20. Same thing for the down one as well. 8 by 20, 9 by 20, 3 by 20, 8 by 20, 9 by 20, 3 by 20. Okay, that's the Venn diagram. On B, it says that calculate the probability that the 2 bricks on the table are different colors. Peter has a third box of bricks, box C. The box also contains only red bricks, green bricks, and yellow bricks. After taking a box from box A and a brick from box B, Amy then takes a random a brick from box C. Amy then puts this brick with the other 2 bricks on the table. Let me have a look. Okay, so the question has to be in here. So B, calculate the probability that 2 bricks on the table are different colors. So we just need to minus from 1 where they are two same colors, so we can get the different colors. So we're gonna minus 1 minus. So it should be the same color schemes first. We're gonna calculate the same, that red and red. So we'll subtract the same color ones, red, red, green, green, yellow, yellow, so that we get the combination of all the other colors where it can have different ones. So 5 by 15 multiply 8 by 20. Plus, another has to be green, green, 7 by 15, 9 by 20. Plus, the last one has to be yellow, which is 3 by 15, 3 by 20. You minus it, you will have 47 by 75, and that is your probability. Okay. For C, it says that Peter has a third box of bricks, brick C. The box also contains red bricks, green bricks, and yellow bricks. After taking bricks from box A and brick from box B, takes a random from box C. Probably that 3 yellow bricks is 19 by 1000. So we'll try to find yellows only, right? So that's 0.2 multiply 0.15. Just change the decimal. Multiply x, that's equals to 19 by 1000, so that's like 0.019. X equal to 0.019 divided by 0.2 multiply 0.15. So that is 19 by 30. And therefore, 30 bricks in, do you call it box C? Yep, box C. And that should be our answer. Okay, we will now go to number 16, where it says that Dan is going to play 1 game of squash and squash and 1 game of chess against. Probably that Dan will win squash as 3 by 5. Did he lose 2 by 5? Chess 1 by 3. That's 2 by 3. Find the probability that he will win exactly 1. So it means if he win 1, he lose another. So that's 3 by 5 multiply 2 by 3. And 2 by 5 multiply 1 by 3. So that equals to 8 by 15. See? Given that Dan won exactly 1 game, okay, very important, he won his game of squash. So we just need to know that he wins squash, right? So 3 by 5 multiply 2 by 3. And the total would be 8 by 15 divided by 15. That equals to 3 by 4. That's why he wins only the game of squash. Okay, so now we go on to number 17. A box contains 8 green counters and 2 white counters. Peter takes a random 2 counters. Probably the people will take 1 green counter and 1 white counter. So 1 green, so that's 8 by 10 multiply 2 by 9 plus 2 by 10 multiply 8 by 9. So that's 16 by 45. And B, that contains 28 blue bees and red bees only. Now should select a B from the bracket random. Explain why the probability of red cannot be 6 by 11, so 28. So N. So that's N plus 28, because we know 28 plus N red beads equals 6 by 11. That's going to be 11n minus 6n, that's equal to 168, which you will have n equals to 33.6, and it is not an integer, right? So therefore we can say that n is not an integer. Okay, and then number C says that the star keeps the first beat and selects the second beat at random. Probability of both beats being different colors 1 by 2. And given that there are fewer blue beads than red beads, okay, therefore the both beads are blue. We need to make sure that they're all blue. So that would be, we know that we have 28 by 28 plus n. multiply n by 28 plus n minus 1. That's equals, oh sorry, we need to multiply 2 because we're integrating, taking 2. That's equals 1 by 2. Just need to solve this. Oops, sorry. So then it should be n squared minus 57n plus 756 equals to 0. So then you'll have n minus 21 or n minus 36 equals to 0. N equal to 21 or n equal to 36. So we need to reject this. Sorry, it is n equal to 36. So that's 28 by 28 plus 36. Multiply, that's 27 by 28 plus 35. That's equal to 30 by 16, and that is your answer. Okay, so now we go on to number 18. So 18, it says that Ted has 2 boxes of buttons, box A and B. Complete the probability of a tree diagram. So 20 buttons in box A, 20 in box B. 13 white in box A, so that's 13 by 20. So this is 7 by 20. Box B, 9 white, 11 by 20. Okay, so it says calculate the probability Ted takes at least 1 white button. We need to make sure that just 1 white, at least 1, so we can just minus it from where it is just not white and not white, right? So 1 minus 7 by 20 multiply 11 by 20. Where you will get 323 by 400. Okay. And then we have C. Says that Ted also has a bag of buttons, 30 buttons in the bag, 8 white buttons. Takes out a random button from box A, button from box B, and a button from the bag. Probably the 3 buttons have 2 of them are white is 337 by 1000. So we have to make sure that 2 of them are at least white. So we need to have a combination of white, white, not white, or white, not white, white, or not white, white, white. We need to plus them. So white, white was 13 by 20. And another white was 9 by 20, right? And the thing that would be white is 30 minus x by 30. So that's equal to 3510 minus 117 x by 12,000. And white, not white, that is 13 by 20. 11 by 20 multiply through x by 30. So that is 143 x by 12,000. And we have not white, white, white. So that's 7 by 20. Multiply 9 by 20. 5 x by 30. So that's equal 63 x by 12,000. And then we will have 89 x plus 3510 when you add them all together equals to 337 by 1000. So that would be equals to 89,000 x plus 3510 1230. That equals to 4044 000. Then you will have take out all these zeros. 89x plus 3510 equals to 4044. And then x will be 89x equals to 534. And x equals 6. So now we get a value of x. Yep. So that should be it for today's video, and I'll see you in the next video as well.